The foundational stones at Baalbek in Lebanon were among some of the heaviest megalithic building stones in the ancient world. The mass of the heaviest stone used in the Trilithon, the three largest stones which form the base of the Temple of Jupiter, is estimated at more than 800 tons. There are only a handful of specialized cranes in the world today which can handle such masses. So how did the ancients manage to do so, and especially with such obvious expertise and precision? The document here references some of the fascinating stories surrounding the site's construction. It says, in surviving folklore from both Egypt and Palestine, there are tantalizing accounts of how sound, used in association with magic words, was able to lift and move large stone blocks and statues, or open huge stone doors. According to Sanchoniatho, Ouranus was supposed to have devised Baetulia, contriving stones that moved as having life. By contriving, the 19th-century English translator of Philo's original Greek text seems to have meant designing, devising, or inventing, implying that Ouranus had made stones move as if they had a life of their own. This is indeed a tantalizing account, especially given that powerful sound vibrations do seem to have the ability to move weights via acoustic lubrication as we see here. It might be telling, and the author seems to agree, that the stones are said to have been quote-unquote designed to move. But how could stones be designed to move on their own? Since sound waves can move objects, it follows that the movements would be significantly more efficient if the stones were cut with dimensions which would resonate with the operating frequencies. During conditions of resonance, maximum vibration or oscillatory energy can be transferred between two or more objects or regions that are tuned to the same frequency or harmonics. Is this what is meant by designing or contriving? Were the huge stones expertly cut with the necessary dimensions which would resonate within a predetermined range of operating frequencies? Another thing I noticed is that the larger brick here, which weighs 28.2 pounds, seems to move just as well or better than the lighter 4.6 pound brick. The larger brick also seems to move more effectively when on its face than on its side. These preliminary observations suggest that a larger surface couples better with the acoustic energy. Hence, a heavier mass can be moved for the same input energy if the mass is distributed over a large enough area. This makes the system significantly more energy efficient. Actually, a number of systems increase in efficiency as they are scaled up in size and surface area. These include pneumatic devices such as hovercrafts, as well as electromagnetic levitation systems. And so it would seem that acoustic systems may follow the same tendency. Could this partly suggest a reason why the ancients worked with such colossal blocks? It seems counterintuitive. Why work with such huge blocks when you could just use a smaller number of smaller blocks? But if the efficiency of your transportation system increases with size and surface area, then it may actually be more logistically efficient to move one huge 100-ton block than moving 100 smaller separate blocks weighing 1 ton each. Another observation is that the geometry of the stones themselves could be integral to their possible transportation via sound vibration. For instance, a small embedded marble mimics a convex protrusion. Such features have been shown as a way to move a heavy mass by hand in conjunction with manual rotation. But interestingly, the protrusion also enhances the oscillation of the stone. This is especially noteworthy as there is a miniature statue in the Manchester Museum in England that is famous for its spontaneous movements, which can clearly be seen using time-lapse photography. An investigation found that vibrations due to foot and car traffic just outside of the museum, along with its unique geometry, namely its convex bottom, resulted in its subtle movements. This demonstrates how geometry can enhance the effect of the vibrations, causing a mass to oscillate more vigorously, again making them easier to move. Does this explain features like the convex bottoms of some ancient monoliths, such as the Easter Island Moai. Before the effects of geometry and vibrations were realized during the investigation into the moving statue at the Manchester Museum, its mysterious movements were ascribed by some to mystical forces. These previous conclusions of supernatural activity were made even in the current era, in which science and scientific thought are assumed to be more prevalent. Have similar conclusions of the mystical been ascribed to the megalithic architectural feats from ancient times? In their quest to create edifices which would stand for an eternity, did the ancient builders develop novel ways to overcome gravity and friction, using the principles of geometry and sound vibrations, which have been subsequently lost to time? Do these principles explain how the Eastern Island Moai walked to their locations, or how the massive Baalbek stones moved on their own?